So today we're looking at radicals versus rational exponents. We've talked about square roots before. Now we're going to look at things that are a little bit, they're similar to square roots, but they're different roots. So this is called the nth root of a. Notice that the n is tucked into the checkmarky part of the radical sign. That's a very technical term right there. You don't want to write the n in front of the radical sign. You have to tuck that n into that little bend. That n is called the index. And it tells you which root we are doing, or which exponent you are undoing. A square root undoes an exponent of 2. A cube root undoes an exponent of 3. A fourth root undoes an exponent of 4, and so on. So if you have like 2 to the fourth is 16, so the fourth root of 16 is 2. They undo each other. You can also write this as a rational exponent. Rational has the word ratio in it. It means fraction. It's an exponent that's a fraction. The nth root of a is the same as a raised to the 1 over n. Notice the index is the bottom of that fraction exponent. The a is known as the radicand. The radicand is the number under the radical. So if you ever hear me talk about the radicand, I'm talking about the number underneath the radical symbol. Okay, for example, what is 4 squared? 16. This symbol we know as the square root. When there's no index shown, it's called a square root. You can put a 2 in there, but the square root of 16 is 4. And if you try it in a calculator, 16 raised to the 1/2 is 4. So I happen to have a calculator here. 16 raised to the 1/2 is 4, because an exponent of 1/2 is the same as a square root. 25 raised to the 1/2 is 5, because an exponent of 1/2 is the same as the square root. Okay, we are going to practice translating between radical notation and rational exponent notation. So first, these are radicals. We want to write them as rational exponents. So the fifth root of 9 would become 9 raised to the 1/5. Number 2, if there's no index shown, that means it's a square root. That means that the index is 2. So if you see no index, it's a square root, and that means that the index is 2. So this would be 15 raised to the 1/2. Try number 3 on your own. 36 raised to the 1/4. Now let's go backwards. Let's start with rational exponents and rewrite them as radicals. So the bottom of the fraction is 3. This would be the third root of 18. Make sure that 3 is tucked into that radical angle, that checkmarky part. And just in case you're curious, because I don't want to hear all the awful ways to say this, this is the third root of 18. I don't want you to say 3 radical 18, because that would indicate like 3 times the square root of 18, and that's not what it is. It is the third root of 18. Okay, the next one, try it on your own. What do you think 8 to the 1/4 is as a radical? Fourth root of 8. Okay, let's talk about when roots exist, when they don't, if they're positive, negative, all that stuff. The third root of 8. Does anyone know what the third root of 8 is?
Decimal. 2.
It's 2. Because 2 times 2 times 2 is 8. If you have an odd index, you are going to have one real nth root. The cube root of negative 8 is negative 2. Because negative 2 times negative 2 times negative 2, not all of the negatives cancel, it would end up being negative 8. If you have an odd number of negatives, the negatives don't cancel. So you can have negatives under the radical when the index is odd. If the index is even, you're going to have 2 real nth roots. For example, the fourth root of 16 is 2 because 2 multiplied 4 times is 16. But if you take negative 2 times negative 2 times negative 2 times negative 2, you have an even number of negatives. The negatives cancel and you still have positive 16. So the fourth root of 16 is positive or negative 2. If you have an even index, the fourth root of 0, what's the fourth root of 0? 0. There's one real root, and it is 0. If it's an even index, and there's a negative under the radical, this is the same as square roots. Can we take the square root of negative numbers without getting imaginary numbers? No. This would be an imaginary answer, so there's no real root. So if your index is even and your radicand is negative, if there's a negative under the radical, there are no real nth roots. There's no solutions. This is a perfects chart. It shows a lot of information. You can use this to raise things to exponents. You can also use it to take the whatever root of things. For example, 6 to the third. 6, you go over to the thirds column. 6 to the third is 216. How about 9 to the fourth? What is 9 to the fourth? 6,561. So do you see how you can take a number and then raise it to whatever column? So what is 2 raised to the 7th? 128. You can also use this backwards. If I asked you for the 5th root of 243, you go to the fifths column, you'd find 243, and then you'd go all the way over to the left. The 5th root of 243 is 3. So on your own, please try to find the 3rd root of 343. Seven. All right, easy peasy, right? Okay, let's go back to the notes. Let's find the nth root of a. So this first one asks for the 5th root of negative 32. So go to your perfects chart. Find 32 in the fifths column. Go all the way over to the left. The 5th root of 32 is 2. But because we're asking for the 5th root of negative 32, our answer is negative 2. Negatives are okay under the radical if the index is odd. So because that index is odd, the negative is okay and your answer will be negative. Number 7, we're looking for the 3rd root of 64. 3rd root of 64 is 4. And then 8, the 4th root of 16. It is positive or negative 2. Because the index is even, you have to consider both the positive and the negative. So on your perfects chart, it would be a really good idea over the even columns to write plus minus on all of them. So plus minus, plus minus. So the even columns, put a plus minus on the top, just to remind you that when you have a second root, a fourth root, or a sixth root, you can have a positive and a negative answer. And then, just for kicks, what if we had the fourth root of negative 81? No real roots. Because the index is even, you can't have negatives under the radical. So before you start, you should think about, okay, wait a minute, can I have a negative under the radical or not? If you can, then go ahead and try to evaluate it. If you can't, because it's an even index, then just say no real roots and you're done. Okay, on the next page, we're going to kind of shake it up a little bit. So we know how to go from radical notation to rational exponent notation. Let's take this a step further. If we have a raised to the m over n, we know that that bottom number is the index. So that's the nth root of a. But then what happens with the m?
It doesn't exist.
Put parentheses around it. The m becomes an exponent. It's the nth root of a raised to the m. We are going to use this rule a lot. Now there's another rule, a raised to the negative m over n, which they're going to try to confuse you with this. It's really not that bad. What do we know about negative exponents?
Can't be on top.
They can't be on top, so this becomes 1 over a to the m over n. So it's really the same thing, just on the bottom. It's the nth root of a raised to the m, but it's on the bottom of the fraction because the original exponent was negative. The fourth root of a raised to the third. It's 8. The index 4 needs to be on the bottom of the fraction exponent. The 3 would then be on top. It's 8 raised to the 3/4. Now, you try number 10 on your own. 45 to the 2/3. Now let's go the other direction. If we have 88 raised to the 2/3, now some of you, the way that this is written can be a little challenging. It's totally fine to rewrite it so that that fraction is vertical so you can really see what's the top of the fraction and what's the bottom of the fraction. This is the third root of 88. Put parentheses around it, raise it to the second. Now, you try number 12. The third root of 54, parentheses around it, raised to the fourth. Okay, evaluate without using a calculator. This is where you are going to want to have your perfects chart. The first one's pretty easy. We've basically done it already. The fourth root of 81.
3.
Is it 3?
Yeah.
Is it just 3?
Yeah.
Plus or minus.
Positive or negative 3. Okay, the third root of negative 8 raised to the fifth. Anytime you see a negative, you should stop for a minute and think, can I do this? Because it's an odd index, yes, we can. So we're going to start by doing the inside part. What is the third root of negative 8? Negative 2, and then take negative 2 and raise it to the fifth. So what is positive 2 to the fifth? Positive 2 to the fifth is 32. If you're multiplying negative 2 5 times, you'd have 5 negatives. Will 5 negatives cancel? No, so it's a negative 32. Negative 49 raised to the 1/2. This is the square root of 49 raised to the first, and then you put the negative on it. So this one's easy. What is the square root of 49?
7.
7. Stick a negative on front.